Hello Dr. Balaji, this is Shangraf Raina, and in this video I'll be explaining 6 different concepts that I've learned from your class and will be implementing the same on the SAS Enterprise Miner tool. So to start with, this is my dataset, that is a car evaluation dataset which has 7 attributes in total, of which the 7th attribute class is my target variable, which has 4 values stating whether a car is in acceptable, unacceptable, good or very good condition, and it has total 1728 number of rows. Now in order to save time, I've already created the workflow in SAS Enterprise Miner, and I've uploaded the file through file import. Now the first concept that I would like to touch upon is to know and understand your data before you start working on it. So this has basically 2 parts here. One is the visualization of the data, and second is to get the descriptive statistical analysis of the data. So in the first part of this, I have basically used multiplot component of SAS Enterprise Miner. So multiplot component basically provides us the bar charts and the scatter plots of the attributes against the class variable, and it usually provides us some insightful informations and relations between our attributes and class variable. Like the one that I found was in the person by class, where you can see when the number of person was 2 here, then the occurring of then the class variable was usually unacc, that is unacceptable. So that was quite an insightful discovery here inside my data, one of the discoveries. Now the second part of my first concept is the descriptive statistical exploration. For that I have chosen stat explore. Through this component I got to know about the variable worth in my dataset. Like you see, safety has the maximum worth followed by persons, and then in the output window, I remember you once told us that before you start predicting on your data, you should check whether the data is correct or not, whether there are any missing values or not. So for that I checked for the missing values in this stat explore result, and it seems that I don't have any missing values in my data set. Also it provides us the data information about our data, like the mode, which is the highest occurring value for a particular attribute, like high is for buying and 2 is for doors, etc. Now the second concept that I would like to touch upon is a data partition. I remember you told us that it is a very intuitive approach to basically decide how much do you want to provide your training, validation and test set data. So I have chosen here 60, 20 and 20, and I came to this conclusion by performing certain HITL tries. So I have recorded that in the Excel. So when I basically chose 10, 80 and 10 combination here for a decision tree, I got the misclassification of 0.24, whereas for 80, 10 and 10 I got the misclassification of 0.096, whereas for 60 and 70 in training set respectively, the combinations I got around about same misclassification for the test set. So I opted to go for 60, 20 and 20 combination. Then the third concept that I would like to touch upon is the variable selections. As I remember, it was explained to us in class that instead of providing a large set of data to our predictive models, it is preferable to provide all the important variables, because usually in fact data it usually hampers the prediction of the data. I have chosen a variable selection here in SAS Enterprise Miner. So this variable selection basically chooses the method of R-square evaluation, and the R-square is basically calculated with the attributes against with the target variable. And as you can see here in the output window, for the variable doors, the R-square value is less than the minimum R-square value that was basically provided in the properties of the variable selection, which was 0.05. And you can also see certain group classes are also created, in which certain classes are grouped together and the R-square is calculated against the class variable. And the same can be seen here for buying persons and maintenance. You can see that the grouped variable with the prefix of G has been added, and whereas the door is rejected completely. The minimum R-square value prescribed that I was mentioning is provided here, 0.005. Now the fourth concept that I would like to touch upon is with the decision trees. Though the fourth concept here is the overfitting and underfitting of data, how to handle and the overfitting and underfitting in the decision trees. So for that I remember that you told us that to handle that we can basically deal with the leaf size parameter here, because providing leaf size basically deals with the smallest number of training observation that a leaf can have. If we provide it a too low value to it, then it will definitely result in an overfitted model, because and if you provide a too high value to it, then it will definitely provide an underfitted model. The model will be underfit because a lot of patterns might go unnoticed and undiscovered here. And whereas the other way of handling was that it is good for a decision tree to be created as large as possible because it learns a lot by that, but there is a possibility of overfitting. So but in I provided a maximum depth of 10 here, but SAS Enterprise Miner basically provides us the facility of auto pruning. Yes, this auto pruning can be observed here. As you can see in the tree leaf report, you can see the node IDs are not in the sequence. The reason being the tree is optimally auto-pruned in SAS Enterprise Miners. We basically decreases the chance of the tree to being overfitted. And also we can see there that the variable importance provided here is 1, 0.9318, 832, 6774 and 5700 for all the variables. Whereas when I first ran it without using the variable selection, I had a door variable here with a variable importance of clear 0. So it definitely helped in increasing my prediction value. The fifth concept that I would like to deal with is the goodness of split, how to decide the goodness of split of a tree. So for that, I remember for all the categorical values, for that we can use entropy, Gini and prop square here, and whereas in the class you explained for all the numerical values we have the option of variance. So since ours is a categorical variable, I have chosen entropy here. And also for that I have chosen the number of rules as 5, which is basically quite good because the splitting rules play a key role in basically making the first split, which is the important split in the decision trees. So here in the 5 splits, the one split will be chosen and compare again the rest of the 4 splits, and the best one will be chosen. So we can see in the results. So here you can see that the first split was made on safety here, and after that we in decision trees basically the goodness of split is decided by the more darker the color, more better is the split. Like you can see in this the split is completely made, like as you explained in class with the high-low example, that if you have to decide the best split, then the number of highs and lows should be completely limited, high in completely separated, that is high in one side and low on one side. Like here the tree node has completely 100% unacceptable on the conditions where group level for persons. So the same goes for this. These all are good splits here. Now the sixth concept that I would like to discuss upon is with the neural networks, and that concept is how to handle the weights by controlling the parameter of learning rate and the momentum. And for that we'll be going into the optimization tab, and I have chosen the back propagation technique here, which is one of the well-known propagation technique. I have chosen 50 iterations. Now there is the learning rate and the momentum here, and I remember that learning rate is basically the handling the rate in the rate of change of the weight, as in if you provide a too low value, then the weight will be changed very slowly and it will take a lot of time for the neural network to provide results. Whereas if the value is too high, then it will start, and then the weights will be changed too frequently, and there is a possibility that in the gradient descent it will start oscillating here and there, and instead of attaining the local optimum solution. And the other one is the momentum. So momentum is basically to control the direction of the change of weight. So it is ideally, as you told us, it is preferable to choose a pretty high normally optimal learning rate and a lower momentum value. That is what I've done here. And the seventh method that I would like to touch upon is, which is a complementary method out here, that in the last you explained us that whenever you have created the predictive models, it is we have to choose the best out of it, or we can choose ensemble here, but I have chosen the best out of it so that we can perform scoring on it. So for that I have chosen the model comparison component, and we can. So you can see that tree undoubtedly outperformed neural network based on the selection criteria of misclassification rate, which is like 0.063 here, as compared to neural network with 0.86. Also it has a lower average squared error, lower mean absolute error, maximum absolute error, and hence tree performed pretty well. So that is all from my end. Thank you so much for watching.